Voyager 1 is the most distant man-made object from Earth ever created. Currently, it is about 24 billion kilometers away and continues to speed into deep space at a velocity 14 times greater than that of a bullet. However, last November, Voyager 1 went silent. Fortunately, just a few weeks ago, NASA managed to revive it, and all systems are now back online. Voyager 1 lives to see another day. This got me thinking, how much further can Voyager 1 travel before it runs out of power, or we lose contact with it? If this iconic image of Earth was captured by Voyager 1 back in 1990, what would we see if we turned the cameras on now? And perhaps most importantly, what will happen thousands of years from now if humanity is no longer around and something or someone finds Voyager? So, let's embark on this journey together. Voyager 1 was launched on September 5, 1977, on a mission to explore the outer solar system and investigate the magnificent gas giant planets before embarking on an endless and solitary journey into the cosmos. While I've mentioned that Voyager 1 is the furthest man-made object from Earth, it's challenging to truly comprehend just how far away it really is. Here's our Earth and the Sun. The distance between them is known as an astronomical unit, which is approximately 150 million kilometers. Voyager 1 launched from Earth on September 5, 1977, on a mission to permanently leave our solar system, traveling at 61,000 kilometers per hour. It took 1 year and 6 months for Voyager to cover 5.2 AU, passing Jupiter and capturing breathtaking images along the way. 3 years and 2 months after its launch, Voyager reached Saturn, marking the beginning of its long and lonely journey. It would take an additional 31 years of travel at this incredible speed to finally cross the heliopause, the point where the sun's solar wind is no longer strong enough to push back against the interstellar medium. This is essentially the boundary of the sun's influence. You might think this is the edge of the solar system, but you'd be mistaken. Fast forward to today. In 2024, Voyager 1 is approximately 24 billion kilometers away from Earth, or around 163 AU. That's more than 4 times the distance from the Sun to Pluto. At this distance, it takes our radio signals 22 hours and 36 minutes to reach Voyager, and another 22 hours and 36 minutes to receive any messages back. While this distance seems vast, in the grand scheme of things, Voyager 1 has barely left home. It will take another 300 years before Voyager 1 reaches the Oort cloud, a spherical shell of icy rocks surrounding our solar system, and an additional 30,000 years to completely traverse it. Now consider where Voyager 1 might be in 1,000,000 years or even 1,000,000,000 years from now, and who might discover it. So, how do we maintain contact with Voyager 1 given its immense distance? Think about it. NASA engineers managed to save a spacecraft launched nearly 50 years ago, all remotely from Earth. That's quite remarkable. NASA communicates with Voyager 1 using their Deep Space Network, a system of large telescope antennas located around the globe in California, Australia, and Spain. These locations were strategically chosen to ensure continuous communication as the Earth rotates. Radio signals are sent from Earth and take about 20 hours to reach Voyager. Once the message is received, Voyager's onboard computers process the instructions before sending a response back to Earth. This response signal also takes around 20 hours to reach us, where it is captured by massive 70-meter-wide radio dishes, along with an array of 34-meter dishes. To give you an idea of how weak the signal from Voyager is, it's transmitted with a power level of just 20 watts, about the same as a light bulb in your refrigerator. Despite this weak signal, the large dishes on Earth can capture these faint whispers from the cosmos, allowing us to receive data about what Voyager 1 is experiencing out there for hours every day. However, signs of Voyager's age are becoming apparent. Last November, Voyager began sending back random strings of data that made no sense. Naturally, conspiracy theorists speculated that aliens had captured Voyager 1 and were using it to send messages back to us, but that's not what happened. Engineers identified the issue with the flight data subsystem, created a workaround, sent the code to Voyager, and waited to see if it worked. Thankfully, Voyager 1 survived. So if communicating with Voyager isn't the issue, why is everyone saying that Voyager is dying? The truth is, Voyager is running out of power. Voyager 1 is powered by 3 radioisotope thermoelectric generators, RTGs, which are nuclear reactors that convert heat from plutonium decay into electricity. Over time, the fuel source diminishes, prompting NASA engineers to turn off non-essential systems and instruments, including heaters and redundant scientific instruments like the camera. NASA has indicated that in the coming years, power levels will drop too low to support critical systems, at which point Voyager 1 will go dark forever, drifting through the cosmos alone for eternity. Now, as we continue with the story of Voyager, it's important to reflect on its legacy. On Valentine's Day, 1990, Voyager 1 was 4 billion kilometers away, leaving our solar system for good. A man had been advocating for one last photo of Earth, but many argued it would be a waste of energy with no scientific value. Thankfully, NASA agreed, and that man was Carl Sagan. The image we received, known as the pale blue dot, may be the most iconic image of Earth ever taken. In this picture, Earth is merely 10% of a single pixel, captured as a tiny speck in a scattered light ray. Yet, that's all we know. That's where you are right now. This leads me to wonder, since Voyager 1 is about to go dark forever, what if we turned it around one last time and activated the camera to take one final family portrait? I ran some simulations, and this is what I envisioned. The sun appears as a faint, blurry dot of light, surrounded by barely discernible planets. While the pale blue dot showed us our home, this represents our cosmic neighborhood, our planetary companions illuminated by the sun. Given the vastness of the universe, this may be all humanity ever knows for eternity. As Voyager 1 prepares to shut down operations in the coming years, it's hard not to ponder what the future holds for this remarkable spacecraft. Once its onboard power is depleted, the instruments will cease to function, and no more data will be transmitted back to Earth, the end of an era. Yet for Voyager, this is merely the beginning of its journey. It will continue through the Oort cloud for thousands of years, eventually leaving the outermost reaches of our solar system for good. Out here, Voyager will orbit our Milky Way every 225 million years, just like us, passing by neighboring stars occasionally, a beacon of our humanity. If someone out there happens to find Voyager, they will have all the clues they need to learn about our little blue planet. The Golden Record contains everything they need to understand who we are, the animals we have, the sounds of our languages, numerous images and audio recordings, and most importantly, where they can find us. So, when that day arrives and Voyager goes silent for good, we can all agree that Voyager 1 completed its mission, and so much more, providing all of humanity with a beacon of hope.